Okay, we'll give it maybe just another 30 seconds, then we'll get underway. Okay, I think we'll make a start there. So good morning, everyone, and welcome to today's Opportunity Support and Information webinar for the Robotics Challenge Statement, which is currently open for responses. My name is Stuart Rowell. I'm a Principal Technologist at the Connected Places Catapult, and I've been supporting a number of these Horizon Scan projects, which we have run on behalf of Network Rail. In a few minutes, I'll be handing over to Alice Payton-Clark from Network Rail, who will give a short overview of the projects and activities which the Accelerated Innovation team at Network Rail deliver, and how these Horizon Scan activities which we're undertaking support them in those goals. Before I do that, I'll just give a very brief short overview of the Connected Places Catapult. So for those who aren't familiar with catapults, catapults are a neutral, not-for-profit organisations which were created by Innovate UK, and they aim to foster innovation and promote productivity and economic growth within the UK. There are currently 9 catapults, which form a network of world-leading technology centres organised around specific areas of UK strength. So, for example, there's high-value manufacturing, digital, offshore, renewable energy, and of course, Connected Places Catapult. The Connected Places Catapult itself was formed from the merger of the former Transport Systems Catapult and the Future Cities Catapult. So with that transport systems background, we still have a strong sort of interest and focus towards any transport related activities. In terms of how the catapults work, essentially they're composed of a number of deep industry technical experts. So there's a lot of expertise that comes from relevant industries. We have a lot of innovation partnerships with organisations such as Network Rail. We also have strong collaboration with a number of the top UK universities to help draw out innovation and research from academia and help to drive it forwards towards commercialisation, and also have a strong link towards SMEs, helping to grow opportunities and to support SMEs in developing their technologies or commercialising their products. In terms of how we kind of operate, I guess there's kind of 3 main focus areas we look at. One is to connect the market. So this is helping to put buyers such as Network Rail in touch with innovative companies and vice versa. We aim to spark new possibilities by undertaking activities such as market intelligence, horizon scanning, or thought leadership activities. And then I guess the main focus is to help accelerate commercialisation of innovation within the UK, to help really drive UK GDP and draw out innovative new technologies and companies. Speaking specifically about this program which we have with Network Rail, we have a program called the Innovation Factory, where we essentially are supporting Network Rail to address a number of challenges which they have in their business and their operations. So broadly speaking, within this program, once a challenge or a business need has been identified, there may be a number of ways in which we can work with Network Rail to support them. We can use our links to engage with industry and academia to help draw out innovation and new technology. This Horizon Scan activity is a good example of an activity on those lines. We may do activities to stimulate the market, so that could be through activities such as hackathons. In our position as a neutral, not-for-profit organisation, we can provide a neutral view on potential technologies which can support our industry partners. And then we can also help to support the development of new and innovative technologies through technical support to SMEs or through helping with demonstrators or trials. So in terms of this project, we've now run a number of these Horizon Scanning activities with Network Rail. where we're essentially looking to identify solutions to the challenges they have. We run these projects in a reasonably standard way, in which we initially work with Network Rail to understand the nature of the challenge they have, and to capture the essential attributes that any solution would encapsulate, and ultimately turn that into the challenge statement document, which I hope you've all now had a chance to read for this robotics challenge. Within this challenge statement, the requirement is not to state exactly what the solution should look like or define an exact specification, but to capture what essentially the end solution needs to be able to do. And in that way, the intention is not to prejudice or exclude any potential solution from being proposed, but really to keep the floor as open as possible for any innovative or new ideas that people may wish to propose. And once that challenge is defined and published, it's pushed out to industry and organisations such as yourselves to offer potential approaches to that solution. In parallel, we will also run a horizon scanning activity where we'll go and try to identify technologies from maybe parallel industries or markets which potentially could be transferred in. And then at the end of these two parallel streams, then we essentially present this information back to Network Rail. And it's really up to Network Rail to decide how they wish to proceed in terms of either selecting from the pin responses and essentially deciding which of those they may wish to move forwards with. So coming now to today's event specifically, the purpose of this webinar is to offer you the opportunity to reinforce your understanding of the challenge, the need, and to clarify any questions which you may have around the process for submitting an idea or requesting any more specific requirement questions which you might have. So this session is intended as a fully two-way engagement activity, so it's obviously a little bit more difficult doing it virtually, but there will be a Q&A session towards the end, which will be your opportunity to ask any questions which you might have. So agenda for today specifically, so the introduction I've just covered. In a few seconds, I'm going to hand over to Alice, who will give a bit of an overview of the Accelerated Innovation Programme within Network Rail. Then we'll have presentations from Network Rail, which will, I guess, reinforce what's on the challenge statement, specifically around the three use cases we're asking to be addressed. And then really the main part will be at the end, the challenge statement question and answer session, and we'll explain how that will work when we get to that point. Okay, so that's it from me. I'm going to hand over now to Alice, who will give an overview of the Accelerated Innovation Programme within Network Rail.
Just one moment whilst I share my screen. Thank you, Stuart. Good morning, all. My name is Alice, and I work on the Research and Development Programme at Network Rail. Within that programme, I work on the Accelerated Innovation team, and our main objective is to drive innovation at pace across the business using an agile approach. This programme of work, the Robotics programme, encompasses 3 use cases that we are looking to find solutions for. And these are as follows. Use case 1, robotic assistance for tubular stretcher bars. Use case 2, automated inspection. Use case 3, robotic assistance for wet bed treatment. Shortly, I will hand over to our route leads, who will give you a comprehensive overview of the challenges relating to each use case. Please note that there will be a Q&A session at the end. So to avoid any confusion, please make a note of the use case if you have any specific questions relating to it. And when we come to the Q&A session, or as we move through, just reference that use case if there's something specific that you would like to ask. I'm now going to hand over to Claire, who will be talking to us about use case 1, robotic assistance for tubular stretcher bars.
Good morning, my name is Claire Smith. I'm a project leader at Network Rail and I'm based in Leeds. So I'm going to talk to you about use case 1, the robotic assistance for tubular stretcher bars. So installation of tubular stretcher bars is a repetitive task regularly undertaken by signalling maintenance teams. This process currently requires approximately 75 kilograms of equipment, which I will show you in more detail on the next slide, to be lifted manually on multiple occasions, whilst also being held in position and bolted or unbolted from the rail. Installation therefore presents a manual handling risk in two ways, with regards to the weight of the equipment during lifting and the possibility of trapping hands or feet during holding or bolting. The motivation behind this use case is therefore primarily health and safety, but there's also a glance to efficiency as well. An example of a concept solution should be shown in your screens. It focuses around a load-bearing arm which is attached to a road rail vehicle, which you would typically use during this task and to transport the tubular stretcher bars to site. The load-bearing arm carries and lowers the equipment into position for its securing, which eliminates the two-person lift. I'll take you through the process in greater detail and explain our essential and our desirable requirements for the robotics solution. Next slide, please, Alice. So the equipment referred to previously is shown here. You can see the colourful variants of motion units, and underneath those is a tubular stretcher bar. And there are also variants of these. One tubular stretcher bar is installed with two motion units attached to it, one on either end. The combination of motion units and stretcher bar is determined by Network Rail standards, and this is prior to the task, and they can be pre-prepared by a competent operator to produce what we'll call the cassette, so the motion units and the bar attached, I'm going to refer to as the cassette from now. This pre-prepared cassette should then be lifted by the robotic arm onto the vehicle for transportation to site, and that will eliminate the manual handling instance, the first instance of that. The number of cassettes that are needed per job can vary, and this is between 2 to 7 in order to complete one switch installation. Ideally, the robotic system will accept all variants of tubular stretcher bars and motion units, and they are all of very similar size and build. Next slide, please, Alice. Once at site, dependent upon the job, typically an old tubular stretcher bar and motion units needs to be removed first. This involves unbolting the motion units, which you can see on these pictures are the yellow ones. We unbolt them from the rail before lifting the cassette from between the rails. It's essential that the robotic arm can complete the lifting element of this task, and it's desirable in the future, perhaps, for it to be able to remove the bolts as well. A new cassette will then be lifted into place by the robotic arm and held there by it whilst an operator is able to manipulate the bar to the correct length and position the motion units in the correct orientation. The diagram on the right shows a long-handed tool, so you should hopefully be able to see the black handle and the orange section, that is used to twist the tubular stretcher bars to extend them. The tubular stretcher bar has a collar, and when this is loosened, it enables rotation of the bar to alter the length. At present, the lifting and holding a bar is an essential aspect for the robot to be able to complete, with the adjustment of the bar and the units being desirable in the future. Next slide, please, Alice. So once the bar and motion units are in the correct orientation, the operator drops gauges between the motion units and the rail, and these measure the distance between the two. There's a specific measurement required for both sides of the rail, and this ranges between 2 to 60 millimeters. And this is based on calculations using the width of the rail, and it depends on which side of the rail we're on, whether it's the open switch side or the other side of the rail. A torque spanner is then used by the operators to tighten the bolts in place. You can see those on the left-hand side diagram in red, the ones that are sort of the two coming in from the side. And obviously this torque spanner has a specified degree of torque to tighten them to. It would be desirable again in future for the robotic arm to be able to complete this task, the measurement and the tightening of the bolts. And that again would remove any manual handling, trapping risk, and would also increase engineering tolerance. So as a recap, at present, our essential criteria for the robotic arm are the ability to lift a pre-assembled cassette of around 75 kilograms, the capacity to hold a cassette in place, enabling operators to safely move around it and complete adjustment and securing or unsecuring tasks. And we have ambitions in the future for the robotic arm to be able to adjust the length of the tubular stretcher bar and position the motion units via rotation, measure small distances between the rail and the motion units, and untighten or tighten the bolts to a specified torque. We welcome any questions in the Q&A session. Please make a note of them and Ian Putcombe will be able to answer them for you. Thank you very much.
Thank you, Claire. We're now going to move on to looking at the challenges around use case 2. So I'd like to take this opportunity to hand over to Dave Clements, who will be able to speak about this further.
Morning, I'm Dave Clements. I'm the Senior Asset Engineer for Rail Management in Wales. Just give you a quick overview of what we're looking for. So we've got various inspection trains that have got an array of inspection technology used to provide data to maintenance and asset management, so we can manage our rails. Sometimes the technology breaks down or the train parting issues mean we've got a section of track that's missed. We can either request another run of the train, which can be disruptive to other routes, or we do have currently another mechanical means which requires us to take a possession of the line, or we do it on foot by pedestrian testing and inspection. So the loss in train-based inspection can limit our data collection coverage, doesn't always fulfill the data capture that we need, which could mean we've got to wait till the next planned run, which could be in 6 months' time, to recapture and update the data that we collect. Pedestrian inspection on foot has quite a few drawbacks. It interferes with other planned inspection work, can cause a backlog in our other planned work. It requires staff to walk on the track. We're moving to 100% green zone, so it requires a lot more planning these days. The speed of the inspection is obviously reduced. The distance that we can cover is limited, and the data collection is limited. We haven't got technology that records as we go currently. Additionally, if we look at adding things like track quality, if we were to look at track geometry as well, a pedestrian means of doing it in what we've got currently for recording, that doesn't have any load, so it doesn't put any load on the track, so that doesn't give us any dips or voiding. So the idea has come up for an autonomous data collection vehicle, which should be more flexible in requesting a rerun of the train or doing things on foot. Something we can put on the track and send on this way, collecting the information that the trains record for us. So being autonomous, it should improve coverage, quality of data, and repeatability of that data compared to what we can do with pedestrian testing. And it may also help us with testing the track under a bit of load. So we're looking for something that can do ultrasonic testing, a means of detecting rolling contact fatigue, a means of capturing the rail profile, rail depth, camera footage along its journey. It needs to be ergonomically friendly, easy to handle. And the most important thing for me is locational accuracy. If you go to the next slide, please, Alice. So it says here, product must find, define, and verify rail defects. Currently, we've got the ultrasonic test train, which gives us suspect defects. I can't see any means at the moment with robotics that may verify suspect defects for us. We're talking robotic arms and probe manipulation and all sorts of things like that for that. So at the moment, we're looking for something that can tell us there's probably a defect there, and then we send someone out to verify it. An example concept in the system could be autonomous vehicle that could be loaded at one access point and travel to a predetermined access point at the other end. Not just for recovering things that the train has missed, but we could use, for say, 7 tunnel as an example, is 4.5 miles long. We could stick it at one end, pick it up the other end, and it records all the rail data we need through that tunnel without having to walk through the tunnel. The system could carry the sensing equipment on board, or we could look at, as I mentioned, ergonomics, having something that's a trolley based that could bolt onto that system. And the sensor tools we've prioritized are those that provide information around rail wear, rail depth, to identify gall and dip, rail loss of rail section. And it's suggested that the device would use the following sensors: cameras to cover both the rail, looking at the rail head, looking around, looking at the rail web, KLD or similar railway lasers that would give us a rail profile, a zero ultrasonic probe, which would be encompassed in probably a roller search unit that would provide accurate rail depth from ultrasonic testing, and GPS would be essential for accuracy of location, and RTPS, which is one of our systems that could tie in with actual track mileage. So when we go out to verify some of the stuff that this autonomous robot's found, we're going to the right place with quite good accuracy. So happy to answer questions and all that.
Thanks, Dave. That was really helpful. If we just move on now to use case 3 and any questions that you have around use case 2, obviously please put those in the Q&A section and they'll be addressed at the end of the meeting. And now let's take this opportunity to hand over to Daryl Harris, who will be speaking us through use case 3, robotic assistance for wet bed treatment.
Good morning, everybody. Just a quick introduction. Daryl Harris. I'm one of the assistant section managers for the Wakefield-based mobile maintenance train. In this case, we're looking for some robotic arm to help with wet bed removal. Currently, it's labour-intensive routines are conducted within the mobile maintenance train, which can be improved upon by the health and safety and maintenance of the teams. At the minute, we have have risks such as repetitive strain injuries, injuries through manual handling, and also exposure to vibrations. We're looking to investigate ways to reduce the likelihood of these injuries and improve where possible. Some of these difficult tasks lead themselves to robotics because of their repetitive nature, or a well-defined workspace, or the style of work such as being labour-intensive. A robotic arm tool developed to conduct some of these repetitive labour-intensive tasks could improve maintenance personnel's well-being. Additionally, the automatic recording of maintenance data during the robotic application's work could improve via visibility of network rail status. Through discussions with the sponsor of the route and the maintenance team, the treatment of wet beds has been selected as an activity that would greatly benefit from robotic assistance. Next slide, please, Alice. As you can see from the diagrams, the area, localized area of wet beds, spoiled ballast, can be anything from 3, 4, 5 beds, ranging up to 60 plus beds. So when the teams arrive on site, they have to break up the spoiled ballast by use of a breaker, which at the minute is a vibrating Hilti tool. The ballast is then removed manually, bagged up and removed by the hoist on the MMT. We can remove in a shift up to 10 tons of spoiled ballast manually. So we're looking at something that can assist with the removal of this ballast, also bag it up and remove it from site or into the intermediate cart on the train. Once the spoils are removed from between the sleepers are then moved to remove the spoiled ballast from underneath the sleepers, creating a good flat bed for us to reintroduce new stone and consolidate against. We're looking at digging a minimum of 8 to 10 inch below the sleepers with a crossfall of about 3 inch, 75 mil if possible. And then after the new ballast is put back into the track, it needs to be consolidated. At the moment, we're using Robel's vertical tampers, but this can still leave us with a 5-day consolidation period after with full traffic before we can lift any hot weather requirements for watching, and inspecting to make sure the track doesn't move. So if we could find something that could help remove the ballast, reintroduce the ballast and then consolidate after, that would be ideal. I think we've covered most of it there. Alice, any further questions? If anybody wants to fire them across, I'll help where I can. Thank you.
Thanks very much, Daryl. Okay, so we have now heard from all of the separate use cases. Just to reiterate, we had use case 1, robotic assistance for tubular stretcher bars, use case 2, automated inspection, and finally use case 3, robotic assistance for wet bed treatment. I'd now like to open up the floor for questions. I will stop sharing my screen just so that we can see that. And now we will begin looking at the Q&A part of the chat. Okay, fantastic. So this first question is for concept use case 2. And it is, I believe Network Rail has 6 survey yellow trains currently. How many inspection robots are expected? Will Network Rail be the only customer, or will train operating companies and civils also be a customer? So I'll put that now to Dave.
We've got 4 ultrasonic test trains that contain most of these sensing probes. So those 4 trains are more or less in full use. So we are looking for something that can do capture this data when we can't plan and when we've got a gap. On Wales, we've got 2 delivery units, and we have used an alternate method of testing other than the ultrasonic test trains. And I would have thought in Wales we'd probably have 1 of these, maybe 2, 1 for each delivery unit. It depends how much we use it. We could decide that if this works, that we don't need the ultrasonic test train on certain branch lines, and test branch lines under our own steam with this bit of kit. So, hope that answers the question. It could be 1 per route. Some routes have got multiple delivery units, so it could be many per route.
Thank you, Dave. Next question is also to you. So what is the cost average per mile or kilometre of automated inspection in the UK?
I'm not sure how much it costs us every year for the ultrasonic test train, but it'll be considerably more than having something we can put on the track and send on its way. So I would have thought if we've got, as I mentioned in the previous one, branch lines and small rural routes, maybe up to 20 miles, 30 miles, if we could test something with this under our own steam, it would probably save us quite a bit of money. So this would probably work out a lot cheaper for us if the ultrasonic test train covered a long mileage and we had this autonomous vehicle testing the smaller miles. I haven't got an actual cost though.
Thank you, Dave. The next couple of questions are for me. So would it be possible to have access to the presentations later? Those are all 3 here. To be continued on that one, I will obviously work with the guys from Connected Post Catapult just to see how we go about sharing that. But yes, if possible, we will definitely share those after the meeting. Thank you. Just answer this one. Brilliant. Again, Dave, so for use case 2, an autonomous or automated vehicle still requires track access to be operated. Wouldn't it be simple to fit such kit to passenger trains that routinely operate on the line, allowing very frequent runs?
It could be a solution, but at the moment we got frequencies depending on our track categories: 8 weekly, 16 weekly, 26 weekly, and up to a year for this data to be captured. If we had more frequent runs, I don't think we cope with the amount of data that's captured. We need a really clever system to process all the data and text and people to analyze the data, because what we do currently is with a 6 monthly inspection, we then got X amount of days to go and verify some of those defects and faults. So it could be something we could look at putting stuff on trains, but this I think would be more under our own steam if we could put something on the track ourselves and send it on its way.
There's also a challenge, Dave, just jumping in there, Rob Ford, around speed. So at the moment, I don't know of anything that can ultrasonically measure the rails at more than 40 miles an hour. Passenger vehicles obviously travel faster than that, so we wouldn't be able to put any ultrasonic equipment on a passenger train currently because there isn't a technology that can capture it at higher speeds.
Yeah.
Thank you. Next question. So I will open this up to the floor because it's not clear the specific use case exactly. So this question is, can a newer positional system be used instead of RTPS?
I'll answer that if you want. RTPS is something we're looking at getting up and running fully with our track geometry and with ultrasonic test train, which will align all our data, and it aligns it to our network model. So whatever, if someone has got some better positional equipment out there, it still needs to be able to map to the network rail network model for mileage accuracy as well as GPS.
Thank you, Dave. Next question. So it's important to know if tunnels are in or out of scope for the inspection vehicles, as GPS is clearly not much help in a tunnel or can be affected by it. So Dave, again, if I can...
What we've currently got with the GPS on the ultrasonic test train, the ultrasonic test train will give us the last known position. So outside the tunnel, it'll give us a GPS location outside the tunnel, and then it'll give us a distance from that GPS into the tunnel. So as an example, back at Severn Tunnel again, it'll give us a GPS at, say, the English portal and a walkout of 2,000 yards. So we go to that GPS, we have a 2,000 yard walkout, and then we'll test X amount distance either side of that to make sure we're in the right place. So yeah, understand that doesn't work in a tunnel.
Thank you, Dave. The next 2 questions are for our colleagues at CPC, so I'll put it to to our colleagues there. So the first being, how do you want us to engage with these projects? Is it via email?
Yeah, I can answer that one. So hopefully you will have come across the link to the application form on the practice page. If you haven't, if you go onto the Connected Places Catapult website and navigate to this particular opportunity, there is a link there to the formal response portal on one of the procurement portals we use. Once you register in there, there's a repetition of the challenge statement document, but there's also a formal response form. And so essentially that is the process. There's instructions in there as to what we're asking for within the response form, but essentially it's an overview of your kind of experience in this kind of area, what you propose to use in terms of a technology solution for this, and where you're able to provide it, some sort of indication on potential costs. So yeah, I hope that answers your question. Like I say, if you go into the Connected Places Catapult link for this project, it should direct you to the right place to respond. And then once your response forms are in, we then process those all at the end of the project and feed that back to Network Rail.
Thank you, Stuart. Next question, also for Connected Places Catapult. Are the future Catapult project pins going to be released via Bravo or something else?
I'll confess I don't know what Bravo is. The process for the future pins will be much the same as it is for this one. So it'll be sort of advertised, if you like, on our webpage, on our LinkedIn feeds and other Twitter feeds. But the formal application process is still expected to be the same as for this one. So via the Proactis procurement page.
Thank you, Stuart. Next question is for Daryl for use case 3. So regarding the wet bed treatment, what is the maximum weight to manipulate?
Yeah, if you're meaning by manipulating, removing from the working area up into the storage cart, we're talking anything up to a ton. We're removing, in the bag.
Thank you, Daryl. Next question. So regarding stretchers, why is the focus on replacing units, as there are currently an issue in terms of them lasting the switch life? So I'll put that to the floor. I think that could be relating to use case 1 potentially. So
can you just repeat the question? Sorry, it's Ian Puckering, the head of maintenance for Network Rail. What's the just repeat? I lost you a bit.
No worries, Ian. I'll repeat that question. So it's regarding stretchers. So why are we replacing the units? Are they not currently lasting the switch life?
Yeah, so the reason that we replace the unit isn't to do necessarily with the units themselves. This is to do with replacement of the switches. The ironwork necessitates us to remove and refit the bars. So sometimes the bars are already there and need taking off and putting back on again, which is the normal process. But we have over the past 12 months to 2 years went through an internal process to upgrade our bars, and the volume of these things across the network is substantial. So there's an awful lot of work replacing our old style stretcher bars with the cassette units that Claire presented first thing.
Thank you, Ian. Next question. So again, for CPC, what are the exact procedures that will be followed for the CPC projects?
So I guess the process is a bit like what I showed in one of my slides. So essentially, we run 2 parallel activities, which is one, publicising this pin and inviting industry to propose technical solutions. And in parallel, we do our horizon scanning activity. And then we bring those 2 parallel streams together, and present our sort of findings and our advice recommendations back to Network Rail in terms of which technologies we think they should be looking at in a bit more detail. But then ultimately it'll be up to Network Rail to decide how they wish to progress and with which supplier or suppliers they would like to sort of engage further and potentially look to develop solutions.
So I can pick up the next bit around what Network Rail are going to do with that. So CPC will deliver us a report with some recommendations. We will then look to run a formal procurement. So we'll go out to market through Bravo, and we'll issue a note to everyone that's attended this session to let them know when and if that's live, and then we would look to move it forwards into a formal rollout if we can successfully get a supplier that can develop something to us.
Thank you, Rob. Next question. So I'm opening up this one up to the floor. And the question is, are you looking for high TRL level solutions?
Maybe I'll pick that up again if you're forward. Yes, we're looking for higher TRL solutions because we want to do something quickly on these 3 user cases. But we do recognise there will be some code development with Network Rail to get these solutions to work specifically for our needs.
Thank you, Rob. Stuart, did you have anything to add there? Because I saw you came off mute, or is
no, that's fine. Yeah, that's more or less what I was going to say anyway. So that's fine.
Brilliant. And this next question is really I'm going to put to everyone, including Rob, from an R&D perspective. So the question is, could you elaborate on the level of technology maturity you are looking for in the proposed solutions? So Rob, I'll first go to you, and then we can open it up to the use cases if you have anything to add there, Rob.
So we're looking for a higher level of technology readiness. We don't want things that are still in the research stage. The reason for that is we want to move quickly. So I've been tasked with trying to get something operating in 12 months, and that's the reason we also want to work in an iterative co-development style. So if there's something in another industry that could have the potential of working for us, maybe not wholly, but meeting the majority of our musts, and then we would work with the supplier to develop the additional functionality that we require.
Thank you, Rob. And just to the use cases, did anybody have anything they wanted to add in terms of that question? Stay on mute if you don't, and then I can move on. Okay, next question. So the next question is, what is the minimum weight for measuring stress and maximum weight for ease of transfer on and off rail?
In terms of the minimum weight, I think that refers to what I put about track quality track geometry. Not sure what the minimum weight would be for that. But enough weight that we could tell if we've got a dip joint or not, I suppose. That's something we could probably come back with. A maximum weight for ease of transfer on and off the rail. I think our ergonomics people have said that maximum someone can lift is 20 kilograms. So something becomes 40 kilograms, it becomes a two-person lift. What I'm hoping to avoid is to have to use some sort of IAB to put this on, and something that we could easily manually put onto the track.
Thank you, Dave. And also, whilst you're here, the next question is again to use case 2. So the question is, does use case 2 cover inspection of trackside assets?
It's not something we've put in, but depending on the cameras and what can be done with the cameras, I suppose we could use it for looking at line-side assets as well.
Thank you, Dave. Next question. So what type of communications network is or would be used for these solutions? So the possible options that have been included in the question are LTE, Wi-Fi, mobile, etc.
Well, I would have thought for user case 2 for the robot, if we could get some live feedback, I don't know, 4G, 5G in the future. But I probably thought what happens currently with like the ultrasonic test train is the data is transferred when the train arrives at its destination and then processed. So if we'd have some sort of onboard laptop or something that would control all that, which would then be downloaded at the end of the shift.
Fantastic. Did anybody from use case 1 or use case 3 want to add anything around communications network? If so, please go off mute.
It's Ian Puckering. So for use case 1, live feed would be advantageous but not essential. Certainly to understand what the robot's doing as it's removing and refitting the bars from a safe distance would be very useful through 4G, but again, not essential to start with.
Thank you, Ian. Daryl, did you have anything you wanted to add?
No, nothing on that one. Alice.
Fantastic. Thank you, Darryl. Darryl, as you'll hear, the next two questions are for you. So first question being, for use case 3, what is the main driver or priority? So health and safety effectiveness or efficiency? Because the solution to resolve each of these drivers is quite different.
For me, and I think for the team, the effectiveness of the machine, if we've got a good effective machine that's doing the job, that will reduce the stress that our staff are, going through, and the repetitive strain. So if we've got an effective machine, that will also reduce reduce the strain and stress that the staff are under, and also give us health and safety benefits.
Fantastic, thank you, Darryl. Rob, is there anything you wanted to add from an R&D perspective there, or are you happy?
I mean, I think I slightly disagree with the statement. I think improving the efficiency of the device and the effectiveness of it will automatically improve the health and safety of staff on site. So I think one of the key drivers, though, is we want to make sure that this delivers something for the users, because ultimately, if it doesn't deliver something for the users and the teams that go and do this work, there's no incentive for them to actually use it.
Thank you, Rob. Next question again for use case 3. So Darryl, on use case 3, how many wet bed treatment excavations are performed each year?
I can only speak for the train I'm working with, and we're doing approximately 250 to 300 wet beds per annum.
Thank you, Darryl. Next question for Dave and for use case 2. So what speed do you expect your automated vehicle to travel at? Do you think that further sensors could be included?
Well, the ultrasonic test train does 30 mile an hour. For testing, it does 20 mile an hour over jointed track. So I'd probably be looking for something if we were to use it for recovery and for distance up to 20 mile an hour. So, and could further sensors be included? Yeah, definitely. We've looked at ultrasonics, we've looked at rail management more than anything, but yeah, further sensors could be included for gauge, level, top, radius. Yeah, could be.
Thank you, Dave. And next question to you would be, is the autonomous vehicle currently a concept, or do you have something under development?
No, it's a concept. There's nothing that we've got under development at the moment.
Thank you. And the next question, I think, again, is to you, Dave, but it's more of a statement rather than a question. So the query is around, so ultrasonics can only run at present at 30 miles an hour. So this could be difficult to use for train operating company trains.
Yeah, that's right. Yeah.
Mm-hmm. Thank you. Next question, is the data collection and analysis expected to be part of the approaches, solutions to the use cases? So I'll go to you, Dave, first, and then I'll open it up.
Well, at the moment, we are working on with intelligent infrastructure and something called EDST, which is a desktop tool for analyzing the data. So I think what we'd be looking for is raw data. If we could have something that gave us exceedances and flagged things up, it would be advantageous. But we have got other systems in place that this data would feed into currently.
Thank you, Dave. Just in terms of data in relation to the other use cases, did anybody from use case 1 or use case 3 want to add anything in terms of their specific project? If not, just stay on mute and we can move on. Fantastic. Okay. Next one to use case 1 here. So regarding use case 1, how quickly will the robot be expected to do the job, and in what level is it needed to be controlled by an operator?
Yeah, it's input, Corinne. So the time allowed for the job would be approximately 30 minutes. And again, I say that with a degree of averaging. An example is at Leeds, we get about 4 hours to renew a half set of switches or a point machine or something like that to do one of these typical installations. In other parts of the network, we might have 8 or 10 hours. The work typically will be done in conjunction with the track engineers. And the reason I'm saying that is because one of the requirements would be that the robot comes along, takes the old stretcher bars off, or the existing stretcher bars, and then allows some further work to be done. and then comes back and refits the stretcher bars accordingly. So it's a bit of a long-winded answer to that, but I guess the task would be approximately 20 minutes to 30 minutes.
Thank you, Ian. Next question. So first I'm going to put this to Rob from an accelerated innovation R&D perspective. So in addition to the 3 use cases shown, to what extent is Network Rail interested in robotic servicing of the fluids, passenger trains in near or the maintenance depot?
So I think the question is, are Network Rail interested in robots that can fix and service trains? Is that right?
Yeah, that seems to be, yeah.
So we don't manage trains. We have a small fleet of trains that we manage, but not enough. But probably a robotic solution would be an economic thing that we'd invest in. We are interested in robotics and the wider user cases, but we've specifically focused on these 3 user cases because we can see a high return on them, and we're quite immature when it comes to robotics at the moment. We don't have many automated processes. We don't really use robotics anywhere. So these were the 3 use cases that were selected out of a number. However, servicing trains wasn't one of them.
Thank you, Rob. So next question. So this is a statement rather than a question, actually. So a potential solution to issues around GPS would be IMU, wheel and visual odometry should be fine to get you the 5 centimetre accuracy if so required. So thank you for that. Moving on to the next question. Again, somewhat of a statement. So up to the 1st of Jan, pins will be on OJU, ATABAT, probably Bravo, most likely. So just for the person or other people on the call who are looking around possible answers to that question, that's there for you. Next question I will put to CPC. So will the CPC also coordinate any potential suppliers into potential consortia, as not everyone may be able to solve the complete challenge, but could have specific useful equipment for consideration?
Yeah, I can answer that. So I guess we wouldn't within this project formally look to bring people together into consortiums. What we would ask though in the response form, if you're if you think there are parts of the solution which you can provide but not the complete solution, then if you make that that clear and indicate which bits you can provide, then all that information will go back to Network Rail, and that they can decide which supplier or suppliers they wish to select for each element of what the solution needs to look like. So I don't know, Rob, I don't know if you want to add anything to the question around forming consortia.
So from a Network Rail point of view, we need to be really careful around that. However, once we got all the, we will welcome bids from consortia. I think it's worth looking at, the other attendees on this call and seeing companies that have expertise in the areas that you don't, and reaching out and seeing if they want to collaborate with you. That would be my advice. I think CPC also offer, as their wider offering, you offer some support in doing that kind of thing as well. So I think maybe if some of the suppliers reached out to CPC beyond this specific event, there would be help available.
Yeah, definitely. Yeah, but for this project specifically, though, like I said, if you indicate which bits of the solution you can address, that will help inform Network Rail as to who they work with going forward.
Thank you, Stuart. Thank you, Rob. Next question. So this is for Ian for use case 2. Does the stretcher bar use case include the removal of the classic type of stretcher bar, or just the installation of the tubular type?
Yes, so both. We've got the classic stretcher bars that the job here would be to remove those and fit the tubular cassettes that Claire referred to. Also, we do an awful lot of work removing and refitting the tubular stretcher bars themselves to facilitate other types of work. So it needs to be a solution that is versatile enough to do both processes.
Thank you, Ian. I'll put this now to Dave for use case 2. Regarding use case 2, in what way would an autonomous vehicle be better than a road rail vehicle?
We do have a means of recovering track with a road rail vehicle towing a bit of kit. Being autonomous, though, it takes away the need for a driver, a machine controller, a cost, an analyst on board. So we're looking at something that maybe a team of 2 people could put on the track and send on its way, pick up the other end, rather than having a bigger team of people to operate the kit.
Thank you, Dave. So this is now going to use case 1. So regarding use case 1, what is the maximum weight the robot should carry, and does Network Rail consider a specific vehicle that the robot will place on that?
Yeah, it's Ian Puckering again. So I think Claire alluded to 75 kg for a tubular stretcher bar. Now this is typically this is a 2-person lift, so it's that feels about right. Over quite difficult terrain, so you're working within switches and crossings. So it's not just about the lift itself; it's also about people taking a reasonably heavy piece of equipment over an area of slip, trip, fall. So looking at the specific piece of equipment, we currently operate a road to rail a 4-wheel drive system with a road to rail trailer associated with it. So our vision, because we've got a large number of personnel trained to operate this piece of equipment, was that the robot would be adaptable to fit on the trailer of this particular piece of equipment, rather than introducing another piece of equipment for the robot to be transported with. There's also another question I've noticed asking about why we don't use MMTs for all the solutions. And my answer to that, specifically for use case 1, is that the logistics of deploying the mobile maintenance train in short possessions over quite complex railway is considerable. The road to rail 4-wheel drive system is far more versatile than that for this type of work.
Thank you, Ian. The next 2 questions are around, more specifically around the R&D portfolio. So I'm going to put these to Rob. The first question being, which time frame is ideal really for the solution to be ready to use?
Which time? Sorry, can you repeat the question, Alex?
Yeah, so the question exactly says, which time frame is the solution should be ready to use? So I think ideally, what kind of time frames are we looking at here to get something live on the track?
As quickly as we can, and the whole purpose of an accelerated innovation program as well is that we try and get something out very quickly that satisfies the minimum criteria. We then work at building out all the extra pieces. So we do something, we learn from it, we iterate, we do more. So we're not looking for a full-blown, can do everything solution from day one. What we're looking is something that can add some benefit to the team on site initially, that we can then scale out and build more developments on top of. So it's a bit of a different approach from Network Rail. Normally we want the end product in 18 months, but actually we want something quite quickly. We're generally working in 12-week cycles, but I don't know, 12 weeks is a bit of a stretch to the night.
Thank you, Rob. And just a final question to you for this section. So what level of funding has been made available for each of these solutions? Are they going to be 100% funded by Network Rail?
That depends on what comes back. Yes, we're happy to fund 100% of development of stuff. However, if we do that, we want more of an IP stake. If the development funding is low from us, we'll want less of an IPR stake. So, but there is funding available to do this.
Thank you, Rob. And a final question on that section actually. Will Network Rail be sharing the current sensor payload and data format? So I'll open that up actually to the floor there.
I talk about user case 2. I don't think we could share the sensor payload and that information because there's several companies that operate and own the equipment on the ultrasonic test train, but we have given each company a sensitivity requirement. So for the ultrasonics, as an example, there's a paper on the sensitivity required for testing. The data format, though, I'm sure we could share that because in terms of our intelligent infrastructure and our desktop application that we're putting together, there will be a data format that will need to come out of the system.
Thank you, Dave. The next few questions are to you, so if you can just steer it there, that'd be great. So for use case 2, what are the minimum speeds you would need for scanning?
Well, 30 mile an hour is the maximum for ultrasonic testing at the moment. Minimum speeds, I don't think we want to go in too slow because we're talking short possessions to put the kit on, get it from one end to the other, and get it back off.
Thank you. And the next question.
That does follow on. Yes, it would be under possession. So.
Brilliant. Thank you very much. I'm going to skip past the next question because I believe that's already been answered by Ian. Following question after that. So, is participation limited to industry only, or does this extend to RTOs, for instance? Can multiple organisations address any of these use cases collaboratively? So I'm going to put that firstly to CPC, who obviously are handling those coming in.
Formally, no, it's not solely open to industry, but I guess I would come back to Rob's comments that what Network Rail are looking for are solutions which are reasonably close to being deployable. So that would, I guess, tend to lend itself more towards industry, but yeah, doesn't entirely exclude non-industry participants. Can multiple organisations address these use cases collaboratively? Yes. For previous PIN challenges, we have had sort of collaborative consortia who have responded, and that's absolutely fine.
Thank you, Stuart. So the next question I think applies to all the use cases because obviously they will differ from site to site. But the question is, does Network Rail have test facilities track for testing the equipment? I'll first put that to Ian from use case 1. If you have anything to add, Ian.
No, nothing to add from me. Thanks for that one.
Thank you, Ian.
I can pick that up. We do have test facilities. We have 2 specific test tracks. We also have a couple of sidings that we use for some basic testing and trialing of the equipment, and product acceptance, which is a critical element to get anything on the railway. Also sits under my team, so we would support any supplier for the product acceptance process.
Thank you very much, Rob. Dave, I saw that you took yourself off mute there. Is there anything that you wanted to add?
Yeah, only just going to echo what Rob said. We've got test facilities with things like known defects in that we use it to calibrate the ultrasonic test string and check them. So I suppose those facilities would be used for this.
Thank you, Dave. Okay, so next question. So this is more around R&D as a whole. So I'll put it to Rob. Also, are there budgetary guidelines in terms of project size or duration, for example?
No, we need something that meets our requirements. So, if we can't afford something that meets our requirements, we need to go back to the drawing board, but I'm assuming we can.
Thank you, Rob. Next question. Is there a target? This is similar to the above, but it's more specific around use case 2. So is there a target purchase price for use case 2 inspection robots? I think the answer there is no, but Dave or Rob, please.
No, no, there isn't. I mean, I'm sure there'll be loads of questions about budget and all that sort of stuff. But we want to. We're doing this exercise because we don't know. We want to know. We want to understand the cost of developing and deploying this kind of technology. So that's one of the areas we need help from everyone on the call today to give us a steer. We've given you our requirements and what we need to make happen. What we need to know from the supply chain is how possible that, how near to delivery is that, and how much they're going to cost us.
Thank you, Rob. Okay, next question. So this is to be put to use case 1. So use case 1, in what level does a robot need to be controlled by an operator? So I think that's quite similar to a question we had previously, but Ian, did you have anything that you wanted to add to that?
Yeah, so I guess my view would be this is an iterative solution. So you would be in the first iteration, you'll be looking at the robot really holding the bar in position while people insert and torque the fixings and adjust the bar to get the gaps correct. But there needs to be a solution that is adaptable, such that the robot can, in fullness of time, torque the fixings up and adjust the bar's length to make sure that the gaps are closed switch and the open switch gaps are correct. And also the final requirement will be some form of LiDAR to produce an overview of the S&C installation as a whole, so it knows what it's done and can download the kind of salient measurements in the S&C.
Thank you, Ian. Next few questions are for use case 2, so for you, Dave. The first being use case 2, have you considered UAVs, for example, drones? If yes, what would be your concerns if you have any?
In terms of flying or aerial drones, no, because we need something in contact with the rail for ultrasonic testing and everything else that the other sensors that we've got on it. In terms of a drone, as in a drone that is a rail-based drone, yeah, that is one of the suppose the things we could be looking at, either remote controlled or probably preferably something that can go programmed from A to B as a drone. My concerns about something that anything that we put on remotely is if it broke down in the middle of nowhere and recovering it. So we'd need to look at means of recovering stuff.
Thank you, Dave. The next question for you, so again around current sensors and data storage. So what's the weight of the current sensor or data storage payload?
That's something I don't know. I'm not sure the weight of the equipment that's currently on the UTU, but we can find that. And the data storage payload, we get gigabytes of data in terms of footage of from the cameras. The data we get from rail depth and from railway is gigabytes of data.
Thank you, Dave. So next question is further to the query about proposing solutions. Are responders expected to respond to all 3 challenges, or you're expecting people to respond individually to the ones we're able to help with? So just to give further kind of answer to that, so as far as we see, the answer would be the latter. So you can respond individually to the ones that you're able to help with, but I'll just open the floor up to CPC, who will go further into what that process actually looks like.
Yeah, I think it's essentially what you just said there. So yeah, I think there's 3 individual response forms, one for each of the use cases. So if you want to put a response into more than one use case, then obviously you can do that in that manner. And then the other point, just to reiterate, I've said a couple of times before as well, if there is only a part of the solution which you think you can provide rather than necessarily the complete solution, that's perfectly acceptable as well. You just, within the response form, just indicate which elements of the required solution you're able to address and how you would do that.
Thank you very much, Stuart. Next question is specific to use case 2 again. So the focus of this use case is largely around rail inspection. How much interest do you have in the ability to survey line sign aspects, for example, such as vegetation?
Yeah, I think I mentioned it earlier that talking of cameras, looking at the railhead web, looking ahead, there's no reason why we couldn't have cameras looking sideways, looking at the vegetation.
Thank you, Dave. Next question again to you. Will the autonomous inspection vehicle work only in a possession, or will it potentially work in traffic and therefore need to appear as if it were a train or for signalling purposes?
We have talked in the concept about having something that can go around in traffic, running around. But then, as we're talking about train speed for testing, 30 mile an hour, be a little bit awkward, I think, if we had passenger trains running around at 90 mile an hour with a little autonomous robot at 30.
I think it's something we'd look at in a longer term, but in terms of getting something done relatively quickly, it's not something we're considering because of the coordination we'd need as an industry would be quite complicated and long, and also all the safety factors would be quite difficult.
Thank you both. Next question is to Rob. One second, thank you. Presumably any system put forward will need to go through the Network Rail DFR process. This is not a quick process and would appear to be at odds with the needs to get something available quickly. Rob, are you okay to speak to that in greater depth?
Yeah, so the DFR can take a long time, but it doesn't have to if you can prove that your solution you've developed is reliable. It only takes a long time if we're trying to backwards fit it. And again, my team will support and help with that. We work very closely with Kim Raymond, who looks after the DFR process. So I don't see it as being a big issue.
Thank you very much, Rob. The next one really is to the floor. So are you looking to procure the products and train Network Rail operatives, or is a delivery service model preferred? I'll first go to Rob, but then by all means, use cases, if you'd like to add anything in addition to that, it would be welcomed.
That's discussions we're having at the moment about what we want to go out to market for. We haven't decided yet. Part of that will be driven by cost. We're moving to more of a service model as an organisation, but in some spaces like the user case 2, it might be more beneficial for us to have more control over it. So we might purchase something in that space. But it's something we're considering. We're looking at both options.
Okay, fine. That's great. Thank you, Rob. I think that was quite a comprehensive answer.
It would be useful. It would be useful to understand the preference, though. So if that's something people want to share in the response, that would help as well.
Thank you very much. I think that answer was pretty all-encompassing, so I'll move on to the next question. So once registered for the RFI, what's the next step? I can't see any documents. That might be best placed to come from CPC, and then we can potentially go back to Rob from an R&D perspective. But if I can just go to you first, Stuart.
Yeah, that's fine. So I believe once you register an interest within the Proactis portal, that should give you access to the response form. And essentially, once you submit that, once the PIN closes, we're able to download all of the PIN responses and we review them. And as I sort of said earlier, provide back our sort of recommendations and feedback to Network Rail. The kind of process after that really is for Network Rail to decide, what the best route forward for them is, whether it's to select one or more than one of the suppliers, and to move forward to looking to develop the technology with them.
So just to be very clear on that, the regulations we follow mean that we will have to go out to an open tender process. Not sure what process at the moment, but it will be an open tender out to the market with a specification, or a challenge-led specification is what we're trying to do. So we're trying not to be too prescriptive, but to open it out and focus on the outcomes we want to achieve and some minimal limits. But we will be going out to market.
Thank you both. So next question is for Dave around use case 2. And you have answered this already, Dave, to a certain extent, so just stay on mute if there's nothing else to add. But are aerial vehicles eligible, or are you looking for ground vehicles only? I think we've previously touched on that, but anything else?
I can pick that up very clear. Air vehicles will not be eligible because we can't operate, and we have a lot of operating restrictions within 50 metres of the track. And also we have overhead line equipment, which was, make it prohibitive in anywhere that we have overhead line equipment. So no is the answer.
Thank you, Rob. And then the final question in today's chat so far is to use case 2, and that is, will you provide a standard or tech specification for the parameters to be monitored during inspection? Also, do you provide any specific sensor equipment?
Yeah, we have got technical specifications around ultrasonic testing, around rail profile, which the companies that currently provide the equipment on the ultrasonic test trains will follow, and that will probably be provided as part of this. Do you provide any specific sensor equipment? As I said, there's equipment on the trains currently, which are provided to us by third-party companies.
Thank you very much, Dave. I'm now going to hand over back to CPC because we have answered all the Q&As from today's section. Stuart, if I can just hand over back to you, that would be great.
Yeah, that's fine. Okay, so yeah, as Alice said, that's brought to an end all of the questions that have been posed in the Q&A panel. First of all, I'd like to thank all of you for joining and participating in all of the questions you've asked. Hopefully, this session has helped to reinforce your understanding of what the challenges that Network Rail are looking to find a solution to, maybe to clarify some questions you might have had around the application process or what happens beyond this project. If there are still questions which are unanswered, there is a contact name on the Proactis webpage where the PIN details are available. If you do have further questions, you can put those that email address, and they will find their way to the right person, and we should hopefully be able to get you an answer to that very quickly. So again, just to quickly recap on the application process. So once you go onto the Proactis webpage, there is a link there to log in and register. Once you click to log in and register, that should then make available the formal documents to respond to this PIN. So they are essentially the response form. So there was a few questions in the question answer around that process. So hopefully that's clarified that. I guess the final point from my side is just to kind of reiterate what it is that we're looking for in this. It's not looking for something as detailed as a formal tender, which looks to address exactly everything that your proposed solution would do, or exactly what the cost is going to be. Really, it's looking for how do you think you might address this challenge? What technical solutions do you think you might have? How do you think the solutions that you have will help to address the challenge that Network Rail currently have? Once all the responses are in, and once we've done our horizon scanning, we present our responses back to Network Rail. Then once the most promising solutions are identified, then further engagement with Network Rail will look to essentially identify exactly what steps need to be taken next, and to look to develop more detail around what your solution might look like. So unless there's Alice, unless there's any final questions that have popped up in the Q&A, I think we can.
We just appear to have had one additional question.
So the final question really is to use case 2. So are aerial vehicles eligible, or are you looking for ground vehicles only?
I think that one's been answered.
Yeah, I've got that one.
So yeah. I can't see actually what the additional question is here. To me,
I think they're just a couple of thank you comments. Okay, brilliant. So yeah, I hope we've answered all your questions. Finally, I'd just like to give thanks to all of the Network Rail team for joining and coming and answering all your questions. I hope this has been a useful session for you. And I'll say if there are further questions, there's a link via the Proactis website to direct further questions. So I think that's all from our side. Again, thank you for your attendance, and we look forward to your responses. Thank you.